So yeah, my name is Martina. I'm a backend developer based in Stockholm, Sweden. I have about 8 years of experience. I've been doing different stuff. I started working as a developer part-time when I was studying, doing research projects. Then I did a little bit of sysadmin as well, and then finally became a backend developer. So for the last 3 years, I've been working for Spotify. Most of the time, I worked in a team responsible for the artist, album, and chart pages. But for a few months, I also worked in an infrastructure team responsible for building the tools that I will be speaking about today. So Spotify is a music streaming service. It started in 2008 in Sweden, and now it has 100 million active users, 40 million paid subscribers, and it operates in 59 countries. So behind Spotify, there's a big tech department with more than 800 employees, divided in about 120 different teams. And on the technical side, we have an infrastructure that follows the microservices architecture. And this allows us to scale well and also work independently in different features, because different features can be powered by different microservices. So typically, each team would be responsible for a few of these services. So if we take a look, for example, at the artist page, we can see that it has different sections. And we can have the popular tracks, the albums, the singles. We have playlists, merchandise. And some of these parts are powered by different services. So for example, that's the popular tracks. And each popular track has a number of times it has been streamed, and that will be powered by a service called Play Count. The albums and singles are retrieved from a service called Discography. If the artist has playlists, we can get those from the playlist service. And if the artist has any merchandise through third parties, we can integrate it in our merch service. So when a client makes a request to the artist service, this one will make also requests to all these dependencies. So Discography, Play Count, Playlists. It will get all the relevant information for that specific client. Let's say it's Android or iOS. And then make an aggregated response with all this data and send it back to the client. So as I said, Spotify has lots of these microservices that power different features. And as we grow, as the organization grows, both in terms of the number of microservices and the number of teams that are working in this, we notice that coordination between us and knowledge sharing becomes harder and harder, but at the same time it's very important. And documentation is a crucial part of this, because it will allow us to work independently between teams without having to interrupt each other, maybe like writing emails or Slack or instant messages, or sometimes if you want to check the API for, I don't know, if we wanted to add concerts, for example, maybe you need to even check out the code. So that's not how you would develop fast, right? So documentation is very important. So our infrastructure right now has more than 1,000 services, and this keeps growing and growing. Also, we have teams that do development in 5 different offices in 3 different time zones. So if you have to wait for an email, and you have to wait maybe for a colleague that is waking up in San Francisco, so that can make communication and coordination really, really slow. So you don't want to do that. You want to try to avoid it, right? So working in these different places, different teams, different cities, led us to do things in different ways, depending on the team you were working on. And if you wanted to check the API specification for one of the services, sometimes a couple of years ago, You would find that in a README file with the code. Sometimes it would be in a bunch of Markdown files, in a specific folder in the repo. Sometimes it could be in the wiki. Sometimes it would be a link to some other document. So it could be in many different places. And sometimes this was up to date, sometimes it wasn't, and sometimes it didn't even exist because who likes to write documentation, right? So what we are trying to do to mitigate this problem is centralizing all the information of our services into one place and make sure that we can gather as much information as possible in an automatic way, so developers don't have to do an extra effort of making the information about their services available to other teams. So this is the tool that we use for this is called SystemSet. It's an internal tool that we are developing. It's a web application that is supposed to be a catalog for all our systems and the parts of our systems, including services. So it does exactly this. It's one place where you can see all the relevant information for services. It's very well integrated with our microservices framework that I would talk about later, called Apollo. And it makes it very easy for any developer to discover this metadata of services. So it looks a little bit like this. At least you can see the important part. This is what it would look like for the artist service I was talking before about in our example. So if you just search for artist service, you can see a bunch of information. The contrast is not very good, but there's a bunch of tabs. Overview, deployment, the activity, if it's a pipeline, some routing. But today I'm going to talk about the last three tabs, which are configuration, API, and system map. So this is the configuration tab. We can see that it has some information about the service running. For example, we can see the build version. It says artist version 2.1 snapshot. So that's actually the version of the Java artifact that is running in production. Then we have container version. It says Apollo standalone 1.1. That is the version of the microservices library that we use. Then we have service uptime from 3 hours to 4 days. And that's because SystemSet will get information from all running instances and make a merge of all that information in this place. So we can see that some servers have been running for 3 hours and others up to 4 days. And then we also see that it's running in Java 8. Below it, we have the configuration. All our services accept different configuration files. And here you can see the merged version of all the configurations that the services are using. So this is a very simplified example. It's usually very long. You could also see, for example, if different keys have different values for different instances, you would see like a diff here, saying this instance has the port 8080, but maybe another instance is running an HTTP server on another port. So this is the configuration part. Then we have the API tab. And this is basically a list of all the endpoints that the service is exposing. In this case, this very simple service has only one endpoint. It's /v1/artist/id. You can only make GET requests. And it has like a very small description saying get the artist page for a specific ID. So here we see a very short description, but we could also have as many details as we wanted. We could add schemas for requests, schemas for replies, maybe what kind of error codes can you get from when you call in this endpoint. And this is only one endpoint, but you would see everything. If you have 10 endpoints, you would see them. And the good thing about this is that no one had to write specific things to get this up and running in SystemSet. Once you launched your service and you put it in production, system set will, once you register the service in system set, it will be able to find out your service and make a list of all the endpoints automatically out of the box. The last part is the system map. This is basically a diagram that tries to give you an overview of how the services are connected around your own service. So in this case, we can see that there's a service called Load Balancer that is making calls to the artist service. And then the artist service is making calls to play count, discography, merge, and playlist. So this makes sense because clients talk to the load balancer routes the request to our service, and then we are fetching information from all these dependencies. So this is quite simple. It's generated automatically as well using a library called GraphBits. And these dependencies, these arrows, are gathered at runtime. And then I will explain later how we do this. So how does this work? System set is this web application that I was talking about. It has a bunch of services in the backend. And when I create a new service, I can register my service in system set and give it a name, an owner or maintainer. It can be me or my team. And then I will also give it a service discovery name. And in this case, it's _artist._http, which means the service name is artist and it talks HTTP. So with this discovery name, system set can make a query to our DNS and say, give me all the machines that are running under this discovery name. It's like here, it's a bunch of hosts and ports. And then system set can talk to each of these servers and make requests to special endpoints that will gather at runtime this information that we were showing before in system set. So these special endpoints are registered or exposed automatically by our microservices framework called Apollo. Apollo is just a set of Java libraries that we use for developing microservices that make our lives easier and helps us develop services faster by implementing common things that you want in all the services, like login, metrics gathering, like requests per second, latencies, connections to databases. It also implements like an HTTP server and HTTP client, and the most important part, which is in our backend, we don't really use HTTP. We use a proprietary protocol called Hermes, and Apollo implements both clients and servers for that, so it makes it very easy to talk between services. It's open sourced. If you are curious, you can check the GitHub page, and we have been using it in production since 2014. So this is an overview of what an Apollo service looks like inside. It has, this one here is Apollo Core, which is the part responsible for managing the life cycle of your service. Then we have the Apollo API, is the classes that you would talk to from your own code, for example, registering endpoints in the Apollo environment. You have your service logic, is basically the handlers of all the endpoints that you are exposing. And then we have some modules that are optional. We have an HTTP server, and this is HTTP client. And the last part, which is the important part for this talk, is Apollo Meta, which is the metadata module. It's also part of the open source Apollo, and it will expose automatically 4 new endpoints that gather different metadata of your service. All this data is gathered at runtime, so when the service starts, it will gather different information from the endpoints, from configuration, etc. So before going into all these endpoints, I wanted to give you like a short example of how it looks like to create and expose a new endpoint in Apollo, or a root, as we call them. This case is like only 3 lines. We want to create a new route. It's going to be async because we want to return an asynchronous response, probably a completable future. And we say we want to expose a get method on the URI /v1/artist/id, which would be a required parameter. And then in the second line, we say, and for each request, we want to handle it through this method. So this is a lambda in Java 8. It says for any request, just apply the getArtist method and use it as a parameter. And then up under here, this is a complete route. It wouldn't need anything else. But if you wanted to, you could add a docstring and say, it's a small description, get the artist page for a specific ID. This is very short and it doesn't add much, but you could add here everything you wanted. And the good thing about this is that this is documentation of your endpoint, or a description. It could be short, could be very detailed, and is literally 2 lines away from where you declare the endpoint, which makes it very, very convenient to just, when you are creating the endpoint, just add a little description and help your peers, right? So the other good thing is that you would keep the documentation close to the code, which, again, it is very easy to modify. So Apollo method has 4 endpoints: for instance information, configuration, endpoints, and code information. And these ones are the ones called by a system set to display the website that I showed you before. So instance info collects short pieces of information of the service that is running, like what's the version of the Java artifact that is running, what version of Apollo are you using, what's the uptime. And apart from system set, this can be very useful. For example, if you're doing a rolling upgrade, you could monitor how the upgrade is going by making requests to these endpoints and getting back the version that is running its instance. So how do you get that information? It's just, you can make an HTTP request with curl, for example. So you would make a query to /meta/0/info. And then you get this small JSON back. And it says build version, artist 2.1, Apollo 1.1, and the service uptime. And this is the information that we saw before in the configuration tab of system set. Then we have configuration. As I said before, Apollo accepts different configuration files in a specific set of paths. So you could have one configuration file in your laptop for local development. You could have another configuration file delivered with your Java artifact, and you could have another one that is overriding the previous ones in, for example, /etc. So when an Apollo service starts, we'll find all these different files, and for each key value pair, it will merge them all together, and depending on the priority of the file, it will make that some keys override some other keys, depending on this priority. So the good thing about this endpoint is that you always get the source of truth about what configuration your service is using. So if you make a request to /meta/0/config, you get back the JSON that the service is actually using. So you might have changed the file in /etc, but maybe you didn't restart the service, so it didn't pick it up. So this is a good tool as well for debugging, for example. You can check, I added this in Puppet and it's not picked up. Then you can just check what is the service actually using, and then you see it right here. This is, again, a very simplified version of a configuration file, and it says, basically it's running an HTTP server on the port 8080. So pretty simple, but you could have lots and lots of keys. Then you have the endpoints one, which is one of my favorites. It will gather for every route or endpoint that you register in Apollo, it will gather that information. And when you make a request to this endpoint, you will get a detailed list of all the endpoints. So if you make a request to /_meta/0/endpoints, you get this JSON back that says, I have an endpoint on the URI /v1/artist/id. It only accepts GET requests, and it also has this extra description or documentation. So this is then what we can use to, JSON is not nice to check, so if I want to check the API of another service, I don't query this, but this is something that you can display in a nice way in system set. The last one is call info, which will, at runtime, make a list of all the incoming requests and all the outgoing requests. And for each incoming request, you can see what services are making requests to your service and what services you are using as dependencies as well. So if you call meta/0/calls, you get first a list of all the incoming, all the services that are making incoming requests to you. So in this case, we saw the load balancer. It's making requests to /v1/artist, our only endpoint, and it's using get. And it also knows that it's using two query parameters, catalog and locale. And in the same response, we also got the outgoing requests. So after the service has been running a while, it has been making requests to these services, and you can see it here, discography, play count, playlist, and merge. So as the service was running, this was keeping information and gathering at runtime, and then you can see exactly, you can make a map of how your services are talking to each other. So again, system set calls these special endpoints, and then it will display a nice and merged version of all the gathered data from all the instances together in a nice way. So after using this for a few months, almost a year now, in my opinion, I think it's quicker and easier to access all the relevant information for specific services, because I know exactly where to go if I want to check something. It's like system set, search box. I type concert service, all the API. The good thing is all this was gathered automatically, so it's no extra work for developers. Then for me, I think it means less interruptions because I don't have to ask other teams about their services. I know that most of the information is going to be in the same place. And it's less boring work because maybe if you have the information gathered automatically, that means you don't have to expose it yourself, right? Some learnings while doing this. Doing different things in different teams when you have a small number of teams is okay, and you can develop faster. But at some point, if the organization is growing, you should think about that growth and how to scale. And sometimes it's easier to just put a little bit more effort into automating all these boring tasks because it will save time later in the long term. Put all the information related in one single place so everyone knows where to go. And if you cannot put all this information in the same place, then you can probably add links to point to the right resources. But at least you know exactly where to go first. And if you're solving an incident, you save up a lot of time. So I would like to encourage you to try Apollo. I think it's a very nice Java library. But if you don't want to change your microservices framework, you can also try these other API specifications. One is called Swagger, one is called Ramel. There are generators for different languages, so you have tools that from your, if you have, for example, an JAX-RS framework, it can read all the annotations and generate automatically an API spec. And then you have also other tools that could put this spec in a nice website. So that's all I had prepared. If you want to know more about Spotify, there's this blog, labs.spotify.com. Spotify is always looking for new talent, so if you want to try it out, spotify.com/jobs or drop me an email. Thank you.
Remote as Spotify.
Maybe we should open an office here.
Yeah, great.
Good, good. Great. So if you have any questions? Oh, so many.
Are you going to put your hand, you get your pick?
This guy's talked too much, I think. Just kidding, I'm just kidding, I'm sorry. It's just hurtful.
I'll buy you a beer.
Oh, cool.
So, you say it's all Java-based, but do any of the teams do things like Clojure or JRuby or anything like that, or is it just strictly Java?
So it's a little bit of everything. We originally started writing in Python. Then we kind of moved away from that for different reasons. And then almost all the things are in Java. But if you go into the data side, for example, some teams use Scala, some teams use Java. Some teams have tried Clojure for monitoring. That was really, really painful. But from my point of view. But you have certain autonomy in choosing the technologies that you want to use. But we are a slightly mature company now. We have tried different things. You had your freedom. And now we kind of decided which things have been working the best for us. And we have invested a lot of effort in making those tools and other tools built in-house for that. So if you want to use something different, you will have to justify it, basically. But it's not forbidden.
Thanks.
I was wondering, how do you handle versioning with all the microservices? So normally you're trying to avoid breaking changes, the simple answer. But if you did have to break an endpoint by changing it, how do you handle that for all the upstream services that consume it?
We don't make breaking changes. So that's how you do it. Basically, for example, this is V1 of the artist service. Artist service is only called by clients. So one good example is that if I want to add something new, I don't remove V1. I create V2, and I redirect all the new versions of the clients will point to V2, or if it's another service, it's the same way. You will try to deprecate the old one, but you monitor closely who is still using your old versions, and you don't deprecate them completely until you are sure that no one is using it.
So does that mean you run only one version of any given service live? Or
No, so one instance can have.
So obviously there's different versions of the endpoints, but is that are those versions all served by the same version of the code base? Does that make sense?
So right now we have almost everywhere commit to deploy, so continuous deployment, which means that if you make sure that you don't break the API, you can have this, and then you can do rolling upgrades, which means that for a certain small period of time, in the same machine, you can run two versions of the same service. One is the new one, one is the old one. And everything should keep working as expected. So you have to think about it, but yeah, you could have different ones running at the same time. But we try not to. Like usually you just upgrade everything.
I just have to do a quick shout out to Clojure. I think it's fantastic. Just like that. That's you, Jeff. Just as an add-on to that, obviously, with your tens of millions of users at any given time, that could potentially result in dozens, if not hundreds, of concurrent users. How do you sort of maintain the infrastructure associated with that when you do have all of these different iterations when you're running a CD and you're not shutting off the to-be deprecated environments?
So first of all, we scale horizontally, so that's how we handle the scale. And
Money associated with cost because of that.
In terms of hardware cost. Yeah, so you just buy more machines. So it's true, we spend a lot of money in hardware, and we also try to keep always spare capacity. But that's something that we know we have to do. Regarding the different versions, if you expect more traffic to a different endpoint, you know that since it's running usually the same version, it's not a problem. You can spin more machines if you expect more traffic. If you are, for example, migrating your service into a new service, this playlist service that I talked about before, now is playlist 4. It was playlist 2, playlist 3, and now it's another version. So we usually try to do seamless upgrades. So maybe you're rewriting this whole service. First, you start working both at the same time by making a proxy, for example, that can redirect part of the traffic to the new one and the rest of the traffic to the old one. You run that for a period of time to check that the new one is working okay, and then you just switch all the traffic to the new one.
Cool. Thank you very much. Brilliant talk. Thanks, Martina.
Thank you.